So this is our warm-up. Were they able to help you?
No, she was not able to help me, but I was able to help myself.
When you cut it off.
I was just sitting there pulling at it, and then I got it over to the other side, and it was a mess, but I got it off.
Okay. So number 2, did you use synthetic division? Good. And did you get the correct thing? All right. Number 3, when we have powers of I, it's always best to simplify all those powers first, and then distribute or combine like terms. So here, did you get 2 plus 5? Fabulous. All right. So are you starting to feel confident for your test next Wednesday? Great. Great. All right. Let's take a look at our book answers. And while you're checking your homework, I'll come by and check for completion.
Your email? This one? And I can probably do this one.
I got 57. 57 plus 2 and 59 times
I got 15.
Did you go on early this morning for class?
I'll get every time.
Did not do the last door, but I see it. Fantastic. I haven't been able to do it. Oh, yeah, the homework.
Oh, there we go.
Right here.
Just drop that.
Yeah. I've already cut it.
You're lucky. Mine's cracked like a front end back.
This kid lucky.
Okay, yesterday I noticed after 3rd period that calculator 22 was missing. Okay?
Oh my
That's my lucky.
So do you see it's still missing? So did anyone accidentally take calculator 22 yesterday? That's Dory. It's 22. Didn't she have her own?
Maybe she took it. Just kidding.
Okay, well, I'll also talk to 1st period and 2nd period about it too.
Oh,
If it
Dory's
doesn't,
missing today.
if it, no, she just,
Oh.
so if it doesn't come back, I'll have to lock up our calculators because I can't let them be taken.
This one is mine. Dora, we were just talking about how your number calculator is missing.
Oh my goodness.
It's on her number.
I'm sorry. Somebody pulled a fast one on me.
Oh.
I want to know that.
Okay, it's all
Why
good.
did you do that?
Me?
Calculator 22 is safe.
Alright, well, I have my own calculator.
Okay, no problems with calculator 22 also. Can't learn sometimes.
So it's
Okay.
like
Alright, now Miss Willis beat me to the punch on this, and she made this answer key. And you know how I said yesterday, old school says you have to separate them. But it's not required. You may see it written this way. Miss Willis doesn't. Okay? So it's not wrong this way. But I like A plus BI form. but it's definitely not wrong. So all these answers on this key will be written that way. Now, earlier today, what some of my students were doing was they were going, oh, I can reduce this one. 2 goes into 6 3 times, and 2 goes into 8 4 times. And they left their answer like that. 3 plus 8 is 4. But if we're going to reduce, we have to do it with every term we're going. So we'd also have to say that 2 goes into 18 9 times. So make sure if we do that, we do it with every term. Take a look at these, see if you have any questions on these.
So we don't have to do that.
You do. It's not required to separate it.
I got. No, like we don't. Do we have to simplify it?
Wait.
Oh
wait,
yes,
wait.
you need to simplify. You should always simplify. Yes. Okay. With the shortcut, you see every time those 2 middle terms are going to cancel. So you can just do the first one times the first one and the last one times the last one. The first one times the first one and the last one times the last one. Because anytime you multiply a complex number times its conjugate, those 2 middle terms will always cancel. So all you have to do is first times first, last times last.
And add those together.
And add them. Any other questions? Yes.
66, how did you get 26 on the bottom?
Okay, so when we do negative 1 times negative 1, we get the positive 1. And then we do negative 5i times positive 5i, we get negative 25i squared. Well, I squared is like multiplying by negative 1, so that's just going to change the sign. These 2 cancel, so we have 1 plus 25.
Thank you.
You're welcome. Yes, Hannah?
Would it be okay if like on 60 or 69 we didn't simplify or on a
You do want to simplify if it will simplify. It wouldn't be counting completely wrong by any means, but I might take off like half a point. Any other questions? Alright, let's take a look at these.
Miss Willoughby, if you were wondering, yes, I did get a schedule change. I know you must have been losing sleep over it. It's a shame.
Connor, you're gonna stick it out.
Yeah, I am seeing you.
It's not worth my overall happiness.
Alright, any questions on 93 or 95? Yes, Hannah?
over number 93 or
No,
Sure.
just got it. I wish I had it before we went to class.
Okay.
Miss William. Oh, sorry, psych. Walk into a room, move and then
Okay.
go out. No.
Alright, so on this one, we've got 3, so we can choose which 2 we'd like to multiply together first. If we notice that these are conjugates, we should notice that all we have to do is the first terms and the last terms. And I squared is the same as negative 1, so 4 minus negative 1 is 5. And then we distribute the 5 through the remaining complex number, 2 minus I, and we get 10 minus 5i. Alright.
Could you go over 96?
96. I to the 35th. Well, 4 goes in there evenly 8 times, and there's a remainder of 3. So it's the same as I to the 3rd. I to to the 24th goes in there evenly. So you can think of it as a exponent of 0 or 4. And then it goes in there with a remainder of 2. So it's I to the 3rd, which simplifies to negative I. I to the 4th is 1, but that's minus 1. And I squared is negative 1. So that gives me negative 2 minus I. Okay? Any other questions? All right. And then 109. Now, first period somebody wrote B because they didn't read the directions and they saw that B was right. Well, the directions said choose the one that is incorrect and explain why. So when we're working on our assignments, I want to make sure we always read the directions and read the problem. Last year on the end of course test, some of us didn't make grades that listed everything we knew. And I think a lot of that had to do with the reading of the problems. They did release some of the test questions from last year's end of course test. And some of the wording is interesting. So we're going to work on more and more word problems because I felt certain my students prepared for the math. But I think some of the ways that the problems were worded were interesting and we weren't ready for that. So we're going to concentrate and do a lot of word problems this year so that hopefully our grades on the end of course test will reflect more what I feel your knowledge is.
Okay, so you know how the letters are now, how we're like, you can retake it, and if you get 100, then this will be your grade.
You're right.
Do you recommend?
What would, to all my 10th graders, this was an option. Not for my 9th graders, because for you it really didn't matter, it doesn't affect school GPA. But for my 10th graders, you have the option of retaking the end of course test. For every 5 points that you score higher than your other previous end of course test grade, for every 5 points that you score higher, it would raise your average 1 point. So let's say you made an 86 previously, but you had a 95 in math class, so you were confused by your 86. You would have to score at least a 91 on the retake to really see any change in your average. And it's been a while since we prepped for it. So you would have to go back and do a lot of prep work and then hope that you're going to make better than that 86 this time. So I don't know what the benefit would be for you. I don't know how much time you have in your day to commit to preparing for it.
I really don't.
Then I probably,
And since I got an A on the EOCT, there's no point if it's only going to raise it possibly 2 points.
What if you scored lower, is it comes down points?
you know, I haven't read that
It
letter.
doesn't change if you
doesn't
score
If
I
you
don't
score
think so.
lower, it is not replaced. Okay. Well, that's a good deal. Okay.
Now, is it just your accelerated class though? Because
All ninth grade students, all students that took the coordinate algebra test.
I got the one this morning, I was the only one in my class, and everyone was like, oh, she failed. And I was like,
No, everybody else got the letter last week when you were absent. Yeah. Okay. All right. Okay, so we found their error in the problem and we explained it well. They didn't multiply by the conjugate. Okay, today we're going to take some previous knowledge that you already have because you know how to simplify some radicals. You have simplified square roots, haven't you? So we're going to take some of that knowledge and we're going to build off of it. And we're going to show you, today we're going to learn how we can convert between radical form and writing it with rational exponents. Yeah, you're doing the same thing.
I think it's gonna look pretty cute.
That's what, yeah.
was this the homework or the class?
That'll be the class.
Tape it up and
So
push it
this-
together. It looks nice.
Yeah, just look at, when you go look at the video, fill that out, so you'll be on the same page as everybody when you come back on Monday.
Well, I'll add to this
to do. I was just,
I know.
Okay, so these ones we already know. When we have exponents, if you multiply like bases, what do you do with the exponents? You add them. If you divide like bases, what do you do with the exponents? You subtract them. If you raise a power to a power, what do we do with the exponents? We multiply them. So these things we already know. And so we're going to add some to that. And then we're going to switch between this exponential form into a radical form. Back and forth. And we're going to simplify radicals. These are fun. Were we ready?
no.
No. Okay. Tell me when you're ready. Okay.
You didn't actually go on.
I just really wanted to.
All right, so here we go. Our first rational exponent, 16 to the 3/4. First thing we're going to do is, before we simplify this, we're going to talk about how we can rewrite it, how we can think about it. So, we just talked about a product of powers. Can we rewrite 16 as 16 to the 1/4 raised to the 3rd? A power to a power.
Yes.
Yes, because 1/4 times 3 is 3/4. Or
Uh-huh.
could we write it as 16 to the 3rd to the 1/4?
Yes.
All those are equivalent, aren't they? Yes, they are. Now, how can we rewrite negative 27 to the 2/3? What can we do? We could write it negative 27 to what power? Pick one. A 3rd. And then what would we have to raise that to? Second. Or we could write it negative 27 to the 2nd raised to the 3rd. This really should have happened. There we go. Okay, when we look at a rational exponent, we can think of it like this, which is what we just did, or we can think of it as this. When we look at this, when it's written as 1/, this is the same as our root. So if I have the square root of 5, this is the same as 5 to the 1/2. If I had the cubed root of 10, that is the same as 10 to the 1/3. If I had the 5th root of x, that's the same thing as x to the 1/5. the denominator, this part, is the root. And the top number is the power that we raise it to. So the denominator is the root, the numerator is the power. So let's go back up and see if we can simplify these. We're going to take it from having a rational exponent, we're going to rewrite it as a radical. 16 to the 1/4 is the same as the 4th root of 16. Now, we're used to working with square roots. And with square roots, we always said, what number times itself gives us this? Well, with the 4th root, you're asking yourself, what number times itself 4 times is 16? 2. 2, because 2 times 2 times 2 times 2 is 16. So the 4th root of 16 is 2.
I was wondering, why is it cubed right there outside of that?
And 2 cubed is 8. The reason it's cubed is because the original problem I gave you right there.
Oh, so you have to keep it there?
Now, could we have raised 16 to the 3rd power and then ask ourselves what is equivalent to that? Well, certainly we could have. But this will be on the no calculator section. And whenever I do one of these problems, I always like to deal with the smallest numbers possible. So I always take the root first, because when I take the root, my numbers get smaller. And then I raise it to the power. So let's look at the second example. We are doing what root here? The 1/3 power is the same as cubed root. So the cubed root of -27. So what number times itself 3 times gives me -27? -3. So this is the same as -3 squared. And -3 squared is 9. So -27 to the 2/3 power is equivalent to 9.
Wait, I'm confused because up there we got. Oh wait, no. Why does it always go down 1? Oh no, each time.
No, it doesn't always go down 1.
You
I
go-
just pick those.
You do the root and then you go to the power, and the power's like.
So I could give you one. I could say, like, what is 64 to the 1/3 power? Well, that's the same as the cubed root of 64 raised to the 1st, isn't it? So the cubed root of 64 is 4. Okay? All right. So, I want you to try these. is that the same as 16 squared? Because isn't that 4 squared? Squared? And we know 16 squared because we've memorized our squares, 120. So that's 256. You don't know 16 squared?
I
15
forgot
squared.
those.
225. 17 squared?
I know up to 12.
296.
I know the standard.
18 squared?
I know one.
Okay.
324?
You don't even
19
know.
squared?
I have 11 squared.
361?
12.
20 squared? 20.
You do.
Alright.
No, I need.
So, now let's go back to something we're pretty familiar with, which is our square roots. Our square roots we're pretty familiar with. Like, we know how to simplify radicals. But now we're going to mix in some variables with them. So we're going to simplify the radical with the variable. Okay. So, well, I want you to think of it like this. Think of it as being like that. Now, square root of 16, we know, don't we? 4. The square root of x to the 4th. Actually, can I change this example? Sure I can. I'm the teacher. There we go. Make it 10. 18 is 5. X to the 5th. Because the square root is the same as the 1/2 power, isn't it? So we can think of this as x to the 10th to the 1/2. And half of 10 is 5. Okay, how would we simplify square root of 32? 16 and 2. And then we have the square root of x to the 6th and the square root of y to the 16th. So this would become 4 root 2. And this would become,
X to the third,
and this would become,
y to the eighth.
nice. Alright, so now let's do a cube root. Alright, I don't want you to write this down, but I want you to watch this. Let's say I didn't give you 16. Let's say I gave you 17. Can we take half of that?
Yes.
We can, but it gives us a decimal, doesn't it? So when you have one like this, that you can't divide by your root, what you do is you break it up into the largest number that does divide by the root times what's left over. So we would break it down to y to the 16th times y. Don't those two together make y to the 17th? Yeah. And y to the 16th is, the square root of that is y to the 8th. And then it would just leave a y under our radical. Does that make sense?
Yes.
Oh, this is new, isn't it? It is.
Then I thought I did this last year.
We did some simpler ones. That's awesome. Okay. Okay, did we do cubes and 4th roots? I don't think so.
Yeah, not those. but
Okay.
it's the first
Alright, so now let's do cube root. The cubed root of -8. And we can think of it as the cubed root of x to the 4th. Now, I show a lot of steps up here so that I don't confuse my students. Now, some of you may be able to go straight from here to the answer. And as long as you're right, most of the time, like 95% of the time, right? I'm okay with that. But if you need to break things up, break things up. Show your work. Do it. Whatever you need to do to get it right. Okay. So this is the cubed root of -8, and I left off the 3 for a second. The cubed root of x to the 4th. Well, the cubed root of -8 is just -2. We're done. But the cubed root of x to the 4th. Does 4 divide by 3? No. So we need to think of this as the cubed root of x cubed times the cubed root of x, don't we?
Yeah.
So what is the cubed root of x cubed? X. And that leaves the cubed root of x. Negative 2x cubed root x. So yeah, look here for a second.
I did.
Yeah. I'm recording this. You can watch it later.
I kind of got lost.
Oh, okay.
Okay, you want me to go over it slower?
Once I just
Right.
started looking at the screen.
Let me say it differently, okay? How many will 3 divide into 4? Okay, not evenly, but does 3 divide into 4?
One.
Yeah, one time. So 1x comes out. How many's left over?
3.
When 3 divides into 4, isn't there 1 left over? 1 stays under. So 1 comes out, 1 stays under. Alright, okay. So let's talk through the next one that way then. Okay, how can I break up 48? Good, 16 and 3. Because we know the fourth root of 16 is 2. Because 2 times 2 times 2 times 2 is 16. Alright, so we would break up 48 into 16 times 3. And then we're going to talk through this one the other way we just decided. Okay, so the fourth root of 16 is 2. It comes out, the 3 stays under. Okay, 4 goes into 5 one time with how much left over? 1. So 1a stays in. 4 goes into 8 how many times? 2. And nothing's left over. So nothing stays under. 4 goes into 14 how many times? 3. And what's left over? 2.
Oh, when you don't have like a
Oh, you
perfect
changed the
root
C to
of-
14.
Yes. Yes, when it's not perfect,
Oh, you just.
when it doesn't divide in perfectly, you're going to have what's left over under the radical step.
The C was.
So how did you get the 2 is because it's 16, 2 to the 4th power is 16, and that's the greatest.
Correct.
That's the greatest factor. Okay.
Oh, you get that. This is easy.
Okay, do y'all want to do one more like that before we move on?
Once you
Okay.
get the hang of it, though, it's just like simple division.
Say that.
Fine. 3 down.
Why do you have so much candy, Jocelyn?
That's cool.
She's like, let me shift it over with my.
Oh, that's not what I meant it to be.
Aw.
There we go.
Is that Z raised to the second?
It sure is.
Oh, I put 27.
Okay.
1854.
Are we doing this one on our own?
Oh, that's why I'm waiting.
Sorry, missed that. My bad.
What if the number on the outside is bigger than the
Then it can't divide into it then. So what does it have to do?
stays in
Yeah.
there?
I got it.
Good job. Oh, that.
What?
Okay.
27 times 3 is not.
27 times 2. Because you have to get the largest factor.
Okay, so 3 cubed is 27, and 27 is a factor of 54, isn't it?
I'm so
Okay,
confused.
so a 3 comes out, and the 2 stays under. Okay, 3 goes into 10, how many times? 3. With how many left over? 1. 3 goes into 9, how many times?
Twice.
3. And how many left over?
0.
0. 3 goes into a 2, No, it doesn't. 3 doesn't go into 2. So it just has to stay under. So our answer is 3x cubed y cubed, cubed root of 2xy squared, xz squared.
I'm confused why you split up the
54.
Yeah.
I'm just simplifying this radical. And so
Okay, yeah,
54 is not a perfect cube.
18 times. Oh,
It's
you
not a perfect cube.
Oh,
Our perfect cubes are 1 cubed is 1,
yeah,
2
but-
cubed is 8,
So-
3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed, are we good? 512, 9
we're
cubed.
great.
But so with like the exponents and the x with its exponents and the y with its exponents, it's basically like simple addition and
Now, the
but with
reason,
the actual number.
okay guys, why can I just divide? Because this, the cubed root of x to the 10, could also be written x to the 10 to the 1/3, right? Those two are the same thing. These two mean the same thing. So really, this is 10 being divided by 3.
Oh, okie dokie.
And you can switch back and forth in between these two forms.
So that's how you do cube roots on the calculator, since I don't have a button for it.
You raise it to the 1/3. If I do cube roots on the calculator, I always do the caret key, and then I do it to the 1 divided by 3. Because it's quicker than going into the math and scrolling down, and yeah. Yes, Beth?
When you simplify expression 4, if you simplified it another way, would you like get the same thing?
That is the only way to simplify it.
That what it is?
Mhm.
Well, what if there's like multiple options?
Then you always choose the largest factor. Always choose the largest factor that divides into it.
So times 5 by 2.
All right. Now, here we go. Cubed root of a fraction. Now, the numerator simplifies nicely, doesn't it? What does it become? X to the 4th. Yeah, you were right. X to the 4th.
Yeah.
The denominator, not so much. There is not a number that is a factor. I can't simplify this, so I'm just left with the cube root of 6. Is that okay? Can that be my answer? No. Oh, no, it's not, because I have a radical in the denominator, and I have to make it go away. Now, with square roots, we multiplied whatever the radical was by exactly the same thing. Because when you multiply the square root of 5 times the square root of 5, that's the square root of 25, right? Which is 5. But let's think about a cubed root. How many of those numbers do we need? I don't just need the number times itself. I need the number times itself 3 times. Because I'm taking a cubed root. So, instead of being able to multiply just by the cubed root of 6, I need 3 of them, don't I? And I've got 1. So how do I get the other 2? I just multiply by the cubed root of 6 squared. Over the cubed root of 6 squared. Because do you see that gives me in the denominator now? The cubed root of 6 times 6 squared is 6 to the 3rd.
Which is just 6 coming
Which
out.
is just 6. So, the numerator just got ugly again. And what is 6 squared, guys?
36.
Okay, good. 36. So my simplified answer, is x to the 4th times the cubed root of 36 over 6. Isn't that simple looking?
Do you think we can do one of those tomorrow for warm-up?
Yeah. Let me rewrite this. So you can tell, well, you can see it. X to the 4th times the cubed root of 36 over 6. And that's my simplified answer. Yes.
Could you just cube both sides to equal like x to the 4th cubed over the cube root of 6?
If it was an equation and we could do something to both sides of an equation, yes. But it's not an equation, it's an expression. Okay? Any other questions?
Yeah.
Yes.
Instead of, okay, how do you say that 40 and then 6? How do you say that?
Right here? Or here?
No, to the right. 3, yeah. How do you say that again?
Cube root of 6.
Okay.
Okay, guys, I can't hear.
Instead of like it was to the 4th.
That'd be the 4th root of 6.
How would you multiply that?
You would have to multiply it times 3 6s.
Okay.
Because you'd have to have 4